5.3, using trig to find angles. We've done this before, but we haven't done it this year yet. This kind of will just give us an intro into what inverse trigonometry looks like. Number 1 says solve for x, round to the nearest tenth of a degree if necessary. So what's happening is we're still using SOHCAHTOA, but we're using it in a way so that we can find an angle. Okay, so we have a right triangle with 2 of the 3 sides. We could do Pythagorean theorem if they simply ask for another side, but they ask for an angle. So you do the same thing and figure out, well, what sides do I have in reference to where this angle is located? Well, I have opposite, and then this would be the hypotenuse, because it's across from the 90. So this would be a sine problem, sine, and then I put of x. Whatever comes after the trig name is always the angle. Would be the opposite 6.5 over, why am I writing hypotenuse? Over 8.9. And so I want you to understand is, what I want you to understand is how to solve this when I just have sine of x. How do I get x alone? Well, just like if we have an equation where it's 2x equals 14, we get rid of the 2 by dividing. We're going to get rid of this, but not by dividing, but there's what's called inverse sine, and that's sine with a little -1. If I do that to both sides, that makes the sine cancel out and leaves me with just x, and then all I have to do is put that on my calculator. Again, we should still be in degree mode. I'm going to do second sine of 6.5 divided by 8.9. And so it gets me 46.9 degrees. Okay, so the opposite of sine or cosine or tangent is the inverse of that function. So let's try one more. Solve for x, round to the nearest tenth of a degree if necessary. This time our angle is here. We have opposite and we have adjacent. That would be a tangent problem. Tangent of x equals, that would be 54 over 72, opposite over adjacent. And so to make tangent go away, what I'm really doing is I'm inversing this to make this cancel, and I'm inversing this side. And so I'll put in second tangent 54 over 72. That would round to 36.9 degrees. Easy enough. Okay, now the next part was a timed thing, but I think I took the timer off, but you have to get so many right in a row, so take your time. It says determine the possible quadrants in which theta could lie. So instead of having x for our angle measure we're trying to find, theta is now replacing that. Theta is just a Greek symbol that represents an angle. So it's saying the cosine of what angle would equal this positive square root of 7 over 5. Remember learning about the quadrants and where you had all students take classes? That might help you on this. Or just thinking about cosine is the x values. What part of the coordinate plane has positive x values? Well, x goes this way, so it'd be positive here in quadrant 1 and down here in quadrant 4. So 1 and 4. Okay. Number 4 is, where's sine of an angle going to be positive square root of 3 over 2? So thinking about sine is the y's. Y values all go up when they're positive. So that would be here in quadrant 1. And then here in quadrant 2. Number 5, cotangent is just the same as tangent, same rules. It's negative. So think about, where is tangent negative? Well, tangent's positive in quadrants 1 and quadrants 3 because tangent is y over x. So when you take a positive divided by positive or a negative divided by negative, it's positive. So it's negative in quadrants 2 and 4. Okay, and then the last one, secant. Secant is the reciprocal of cosine. Remember, that's just your x values. Where are your x values negative? When you go to the left, so that would be quadrants 2 and 3. And that's all you're trying to do.